Okay, so we're now talking about a object going round in a horizontal circle like this, but suspended from a point. Okay, so it's moving around like that, but it's suspended from this point here. Okay, and it's got a mass m. Now we know that there's going to be a weight acting downwards here equal to mg, and we know that there must be, maybe let me do this in a different colour. Okay, there must be a centripetal force acting inwards here equal to mv squared over r. So those are the two forces that are acting there on this object, but there's also then the tension force here. Okay, now the tension force from the string acting in this direction provides both the centripetal force and the force that is in the opposite direction to the weight. Okay, so this tension force is providing the force that holds this ball up from falling down due to the force of its weight, so it keeps it suspended, and it's providing the centripetal force. Okay, so what we can say here is there's two components to this tension. The first one is horizontal like this, okay, and that provides the centripetal force. So this is T horizontal, okay, and then there's also a vertical force, okay, of tension, or a vertical component I should say. So there's two components to this tension. The horizontal component is providing the centripetal force, and the vertical component is providing the force opposite to the weight that stops the ball from falling, okay, and keeps it suspended in this horizontal circle. So therefore we can say this, okay, we know that this is your hypotenuse, this is your opposite, and this is your adjacent, okay, so we know that the vertical component of the tension is equal to, well, if you think about it, we've got the vertical component of tension is the adjacent component. The tension is the hypotenuse, okay? So we know that cos theta equals adjacent over hypotenuse, okay? We're looking for this adjacent here, so we know that T vert is equal to T cos theta. So the vertical component of tension is equal to that. The horizontal component is equal to, this is the opposite, this is the hypotenuse, and we know that sine theta equals opposite over hypotenuse. So we're looking for the opposite here, so we know that that's going to be T, because that's the hypotenuse component, multiplied by sine theta, okay? And therefore we can say this, we know that T cos theta, the vertical component, is equal to mg. Okay, it must be equal to mg because this ball isn't falling or moving up, it's staying at the same height as it moves around in this circle. So these two forces must be equal and opposite. There's no vertical resultant force on our ball. Okay, and then we know that the resultant force horizontally is mv squared on r, and that's provided by the horizontal component of tension. So T sine theta is equal to mv squared over r. Okay, so when you've got a ball moving in a circle like that, when it's suspended, these two equations are the equations you need.